Welcome to Patukala College of Commerce and Management. This is Abhijit Paradkar, and today we are going to learn about measures of dispersion. Let us see what is the measures of dispersion. The measures of central tendency gives us a bird eye view of the entire data. They are called average of first order. It serves to locate the center of the distribution, but they do not reveal how the items are spread out on either side of the central values. The measures of the scattering of items in a distribution about the average is called dispersion. The measures of dispersion are also called average of the second order because they are based on deviation of the different values from the mean or the other measures of central tendency, which are called average of the first order. Now we will see some definitions of measures of dispersion. According to Bowley, dispersion is the measures of the variation of the items, and according to Konar, dispersion is a measures of the extent to which individual items are vary. Objectives of measuring dispersion. Number one, to determine reliability of an average. To compare the variability of two or more series. For facilitating the use of other statistical measures. And basis of statistical quality control. Properties of measures of dispersion. It is easy to understand, simple to calculate. It is based on all observations. It is not affected by extreme observations, and it is capable of further algebraic treatment. Types of measures of dispersion. Measures of dispersion is divided into two major parts. Number one, absolute measures of dispersion and relative measures of dispersion. Absolute measures of dispersion is expressed in the same units in which data is expressed. For example, rupees, kilograms, liters, kilometers. And relative measures of dispersion in the form of ratio or percentage. So, it is independent of units. It is also called coefficient of dispersion. Now let's see some methods of measuring of dispersion. So here methods of measuring of dispersions are range, interquartile range and quartile deviation, mean deviation and also standard deviation. Let's see what is range. Range is the simplest measures of dispersion. That is defined as the difference between the largest and smallest value in the series. That is R equals L minus S. So here R denote range and L stands for largest value and S stands for smallest value, and the coefficient of range equals L minus S divided by L plus S. Now we will see some merits of range. Range is simple to understand. It is easy to calculate, and it is widely used in statistical quality control. And here some demerits of range. Range is cannot be calculated in open-ended distribution. It is not based on all the observations. It is affected by sampling fluctuations, and it is affected by extreme values. Now we will see interquartile range and quartile deviation. Interquartile range is the difference between upper quartile and the lower quartile. It covers dispersion of middle 50% of the items of the series. Symbolically, it is denoted by Q3 minus Q1. That is, difference between upper quartile and roll quartile. Now, quartile deviation. So quartile deviation is a half of the interquartile range. It is also called semi-interquartile range. Symbolically, it is denoted by Q3 minus Q1 divided by 2. Coefficient of quartile deviation. Coefficient of quartile deviation is the relative measures of quartile deviation, and coefficient of quartile deviation is denoted by QD, that is Q3 minus Q1 divided by Q3 plus Q1. Mean deviation. So here, mean deviation is also called as average deviation. It is defined as the arithmetic average of the deviation of the various items of a series computed from measures of central tendency like mean, median, or mode. So, mean deviation from mean equals summations of mod of x minus x bar upon n. So here x bar means mean. Same thing, mean deviation from median equals summations of mod of x minus me upon n. And again me stands for median. And mean deviation from mode equals summations of mod of x minus m upon n. And n stands for mode. Coefficient of mean deviation from mean. So coefficient of mean deviation from mean equals mean deviation from mean upon mean. Coefficient of mean deviation from median equals mean deviation from median upon median. And coefficient of mean deviation from mode equals mean deviation from mode upon mode. Merits of mean deviation. Mean deviation is simple to understand, easy to compute, less affected by extreme value. It is useful in fields like economics and commerce. Comparison about formation of different series can be easily made as deviation are taken from central value. There are some demerits of mean deviation. Mean deviation is ignoring plus sign are not appropriate. It is not accurate for mode. It is difficult to calculate if the value of mean or median comes in fraction. It is not capable of further algebraic treatment. And it is not used in statistical conclusion. Standard deviation. Standard deviation is most important and widely used measures of dispersion. It is first used by Carl Pearson in 1893. It is also called root mean square deviation. It is defined as the square root of the arithmetic mean of the squares of the deviation of the values taken from the mean. It is denoted by sigma, and sigma equals square root of summation x minus x bar square upon n. Now we will see simple example. Find the range, quartile deviation and mean deviation for the following sample dataset. And my dataset is 7, 11, 11, 20, 13, 20, 28. Solution for range. So range means largest value minus smallest value. So in the given dataset, largest value is 28 and smallest value is 7. So range equals largest minus smallest. So here largest is 28 and smallest is 7. So 28 minus 7 is 21. So in that case range equals 21. Solution for quartile deviation. So quartile deviation equals Q3 minus Q1 divided by 2. So in that case we need to arrange given series in ascending order. So ascending order is 7, 10, 11, 11, 13, 20, 20 and 28. So here n equals 8, that is number of observation. So Q1 equals 1 into n by 4th term. So n is 8, so n by 4 equals 2. So 1 into 8 upon 2, that is 2. So second term in arranging sequence is 10. And Q3 equals 3 into n by 4th term. So 3 into n by 4th means sixth term. A sixth term in arranging sequence is 20. So therefore Q3 minus Q1 divided by 2, which is equals 20 minus 10 upon 2. So 20 minus 10, which is equals 10. So 10 upon 2, which is equals 5. So quartile deviation is 5. Mean deviation. So here mean deviation from mean equals summations of mod of x minus x bar upon n. So in that case we need to calculate mean. So mean equals summations of x upon n. So here summations of x equals 120 and n equals 8, that is number of observations. So 120 divided by 8, which is equals 15. So your x bar equals 15. So now we need to calculate mod of x minus x bar. So x is 7, 11, 11, 20, 13, 20, 10 and my x bar equals 15. So mod of x minus x bar means 7 minus 15, which is equals plus 8, because mod always take positive values. So next 11 minus 15 equals 4. Again next 11 minus 15 is 4. 20 minus 15 5. 13 minus 15 plus 2. 20 minus 15 5 and 10 minus 15 plus 5. So therefore summations of x minus x bar, which is equals 33. So now mean deviation from mean equals 33 divided by 8, which is equals 4.12. So mean deviation from mean is 4.12. Thank you. Have a nice day.